Okay, DT paper 2, this is 2021 November for product design A-level AQA. I also already answered a bit of it while I was doing it the first run, but my audio wasn't recording. Figure 1 and 2 shows two-step ladders. Figure 1 shows a wooden one, whereas Figure 2 shows an aluminium one. Figure 1 is created by wooden wasting techniques and joined by adhesives and screws and has a clear varnish on top of it. Figure 2 is made through aluminium extrusion, joined by nuts and bolts, and is self-finishing. Now I talked for 8 marks for ergonomic and 4 for safety. So what I said for ergonomic factors is that Figure 1 is created from a thermal insulator, which is wood, which is easy to work with in hot and cold environments because it's not going to absorb the energy. Whereas Figure 2, hot and cold environments, the actual ladder will become too hot or too cold to handle, which will be hard to work with. Wooden ladder is created from natural materials, which will splinter due to its structure, and we can also see, it's very hard to see, but the grain is like this, so it's going to break over time. Whereas Figure 2 will hold its structure for a very much longer time. Figure 1 in damp environments will also distort because wood distorts in water or moisture, whereas Figure 2 will also hold stable in all environments. Figure 1 will wear out much faster as well because it's wood and it does not have as much of an abrasive resistant surface. So as you use it or as the person uses it, it's going to wear out and break basically after a long amount of time. Aluminium is a much harder material and it won't wear out so easily. We also talked about, now this part is design safety. We said that Figure 2 has a handle on it which allows the person to climb on and then stand properly and safely while holding on. But Figure 1 does not have such handle or anything. Figure 2 is also an electrical conductor, so it's not suitable for electric works. Should a live wire touch any part of this, it's going to electrocute the person standing on top of it, as they're going to be holding on to it. Figure 1 is an insulator of electricity, so it's much safer to work with this during electrical operations. Then I talked about joining methods. Adhesives will eventually break out, as well as the screws, and nuts and bolts can also loosen, so they both will break, but they both have a wide base, allowing the ladder to take the load very easily. And one more small thing is that we can see for safety that the aluminium ladder has wooden these rubber, or not sure what it is, but it has extra material to stop it from slipping, but this one, Figure 1, does not. Okay. Figure 2 Figure 3 shows a 2D view of a 2-meter step ladder. Okay. The step ladder is angled at 15 degrees from the vertical wall and stands on the horizontal floor. Okay, so this is 90. The ladder has 5 steps with even spacing of 300 millimeters between each steps. The first step is 300 mm from the bottom of the ladder. Calculate the vertical height of the 5th step from the floor to the nearest mm. Okay, so it's basically asking us normal SOHCAHTOA, normal trigonometry. So we know that this is 90 degrees, this is 15 degrees, which leaves us with 180 minus 105, which means this is 75 degrees. We also know the entire length of this is 2000, but it's asking us for the 5th step, which is 2. This is the 5th step. Now 5th step would be 1500. And it's asking us for this height over here. So we have the hypotenuse, we have the adjacents, and we have the obtuse. So for this we can use cos. Cos is equal to a over h. So cos 15 is equal to a over h, where our a is what we're trying to find out, and our h is 1500. Now if we do 1500 times cosine 15, we'll get A. And if I do that, we do make sure your calculator is in degrees. I get 144.88. Now make sure, I just saw this in the end, to the nearest mm. So that's actually 1449 mm. So just make sure you don't forget that. Okay. Describe the testing procedures required during product development to ensure a stepladder is safe for sale. Okay. So this question is asking us that if we were to make a stepladder, how would you make sure that it's safe for anyone else to use once it's on the market? So first thing I would do is I would have a small group of testers or users to check ease of use, like how easy it is to use. So ease of use, and yeah, another thing we could check is how readable are the instructions, or safety warning. Now more of an industrial test is they could check weight applications, like they're going to apply different amounts of mass to it at different angles. To make sure like it doesn't snap or break and it's able to take weight needed for at different angles, of course. Step ladders foldable to ensure folding capabilities. Don't on the finger itself. You could test the material that you're going to use. And we can also have it go through BSI testing, because if it goes through BSI, it's safe. Repeated testings, hinges and stuff like that, or closing mechanism. Okay, this is question 4. I already did this, but I didn't record the audio, so I'll say through it again. Figure 4 shows a range of safety instructions used on a loft ladder. So here we can see it. The question asks us to analyze and evaluate how the images shown in figure 4 effectively communicate the safety instructions to the user. Now what I said for my first point is that these images, just looking at it, they're very small to understand and they have a very large lack of color. They don't have any color in it, which is hard to differentiate the different points. Like the tick could be green and the cross could be red to further differentiate. These images, such as the first and the second and these ones, they do assist in understanding the safety instructions. The ticks and crosses also help further understanding, which tells us from a glance that you shouldn't have to use this next to electrical stuff. It is aluminium, I assume. 2D images in the 5th stage is hard to understand because it doesn't quite show what it means by vertical clearance or horizontal clearance, but It does give it a text format, which allows us to understand it. Stage 8 has standardized symbols, such as this electric hazard, which makes it further easier to understand. Stage 6 image, which is this one. This is extremely unclear because the first time I saw it, I just saw a person with a briefcase and a tick, but the text allows us to understand. But what would be better is that if they said that your grip should be perfectly on it to help so that you don't fall off. State 2 specific forms of anthropomorphic data used in the development of a step ladder. For this, I said max and minimum, well, just maximum weight of 99th percentile of males, because males are heavier, so you would use the data from males. Um, your grip diameter, which would also be for the 99th percentile of males, and the width of foot. That's the third point. You don't need it, but that's also the 99th percentile of male. All of this just to make sure that the ladder works for 99% of the population. Two types of nutrients associated with the circular economy. This is biological nutrients, stuff that can easily degrade in the natural environment, and technical nutrients, which do not degrade naturally in the environment easily and are usually human made. Outline how a manufacturer could personalize mass produced products to an individual customer's requirement. Well, this basically means that the product would be customizable um, after it has been produced, not during its production. So for this is called mass production, should they ask. Manufacturers can have standardized fittings on their product with modular design to allow add-ons to be attached to the main product. So the main product could be like a Lego set, like a base Lego set, and they could have add-ons for that Lego set for like electronic add-ons or design add-ons or just extra bricks, and this allows the customer to customize how they would like to buy the product. Pigments can be added to the said product line to add variation to the colors, but this is a very basic level because all it does is it changes the colors, but it is still a customer might require it to be red, blue, green, pink, or different colors. Engraving or etching allows the customer to have personal message engraved or etched onto the product. An example of this is the Apple AirPods, where you could laser engrave your name or a text onto your AirPods so that if it got lost, it could be your number or your name so that it would be easily, and that makes it very personalized. Online applications can allow the user to self-design. So for example, if you're buying a Tesla online or something like that, you can change the rims, you can change the self-driving options that the company offers, but these are usually predetermined set of options so that they would, if you wanted to choose different rims for your car's wheel, you would have like 5 options to pick from, or different color for the car, you'd have 10 colors, or self-driving has 3 options and stuff like that. Okay, question 8 states, explain the benefits of using laser scanning for quality control in mass production. Um, this is when a laser scans the product for tolerances, and it's usually done from a distance. So what this does is, the first point we can say is the benefits, no disadvantages. So what we can say, it is done without contact, which first of all does increase hygiene after COVID, but also allows scanning of hot products. So like let's say you just had plastic or polymers come out from being molded and you want to check if it's correct. Uh, this can be done from distance, would be, we can just turn this into a second, from distance. It can be scanned from distance, which allows scanning for hot products, um, which may not be done after forming, because you can't touch it, so you use it from a distance. Um, it has extreme levels of accuracy, of accuracy, and can also measure multiple widths slash lengths, or rather measurements, rapidly. So not only does it do it fast, it does multiple at once, or very quickly, which makes it very fast. It's non-destructive, which means no damage or deformities is caused to the product. And one more point we can say is it can be linked to PCs or computers with 3D model. So, which makes it more precise in terms of its check. Okay, question 9 shows some packaging for biscuits. The box is made from carton board. The polymer wrapper, which is this film over here, is LDPE film. And the biscuit tray is polyethylene terephthalate, or PET. The question asks us to analyze and evaluate the environmental impact of the three packaging components. In your answer, you should refer to raw materials, product manufacture, and disposal, end of life. Okay, so the box, well, its raw materials should be approved. The box should be FSC approved, which stands for Forest. What this basically means is that the wood or the timber that comes in should be FSC approved, which means it is renewable, which also means that for every tree they cut down, 3 new trees are planted, so it's a very sustainable way of cutting down wood. That's the raw material. It's wood, and it should be FSC approved, which is the environmental impact. The next thing it talks about is product manufacture. So the printing is done by offset lithography printing. Which requires ink, of course. Now, when it requires ink, it becomes very hard to recycle it. One more thing we can say is that the carton is cut out with die cutting, which is when they have like a big cookie cutter for the board and they just slam it down, cut the board, or crease it wherever required, and that's how it's done. But this creates a waste card. In the end of its life, it is disposed of. Oh yeah, adhesives are used. Join the box together. It becomes hard to recycle. This is because the ink and the adhesives, they act as contaminants. So it becomes hard to recycle it. So sometimes it gets thrown away, or if it can be recycled for like these flap sections, then they are. Also, you could mention, if you're running out of points, that energy is used within all processes, like every time energy is used, which is an environmental impact. Polymer wrapper is created from LDPE. Okay. Um, so its raw material is a finite source, oil. So that's our point for raw material. But another thing we have to mention is that we can see how clear it is over here, which tells us that it must be made from virgin polymer rather than recycled. So what virgin polymer basically is that the polymer that has been directly created from oil straight to being used rather than being recycled, because when it's recycled it does not have the clarity of virgin polymer, and also it's not very hygienic for the food when it's recycled, so it has to create new every single time, which is not very good. Its product manufacture is done by calendaring, which requires extensive heat plus pressure to make it come down to that point, which requires a lot of energy. And we can see that to join all of this together, you can crimp it together with heat, which means no extra adhesives are used. And as of its disposal or end of life, it can be easily recycled. It can be easily recycled as it's LDPE, which is a common thermoplastic which can be recycled, so it's not very wasteful. The PET biscuit tray. For this part, which is PET, the raw materials could be recycled, but could also be crude oil, which is again finite resource, not very good. PET is usually vacuum formed, which requires heat and electrical energy to press it down. The waste polymer from cutting it, trimming the edges after vacuum forming, can be recycled, so that's good. So that's good. It can also be recycled in the end, recycled after use, as it's a thermoplastic. But we can see that it's black, so that might cause issues in recycle. Pigmentation of black color causes recycling issue. State 2 reasons why a barcode is used on packaging. Um, to allow for accurate stock management, because once you scan a barcode, it tells you how many items you still have left in the shop or in the packaging. Um, allows scanning. And displays product specific information. Yeah, very simple question. Okay, let me zoom out for this. Figure 6 represents the coverage of different printing ink colors on some packaging. We can see black, yellow, magenta, and cyan. Table 1 shows the cost of different cartridges and the ink each cartridge can cover. Okay, so how much they cover and how much they cost. Packaging has a surface area of 0.6. Show that 5 yellow cartridges will be needed for 1,000 packages. So yellow has a ratio of 30 over 360 over the entire circle. So that's the ratio we have for yellow being used in printing. Now overall, since yellow is out of 0.6, we multiply that to see how much area yellow will be covering. So 0.6 times 1 over 12, which is 1 over 20, or 0.05 meters squared. So that's how much area yellow will cover on the paper. And now we just simply multiply that by 0.05 times 1000, since we're doing 1000 packages, and we get 10, I believe. 50, sorry. 50 meters squared. Now, each yellow covers 12 meters, so we do 50 divided by 12 is 4.16 recurring. Now, of course, you will need 4 to finish 4.16, so yes, you will need 5 to finish the printing job. Because any less, you'll be left out. Calculate the total cost of full cartridges needed for 1000 packages. Okay, so let's just see. Black was 1 over 6, cyan was 3 out of 8, and magenta was 3 out of 8. So 3 out of 8, 3 out of 8, and 1 out of 6 for black, cyan, magenta, and we already did yellow. So now if we do that, we will get 3 over 8 as being, sorry, 3 over 8 times 0.6, which shows how much magenta will cover. It will cover 0.225, which is the same over here, 0.225 it will cover. And black is double than yellow, and yellow is 0.05, so black will be 0.1 area covered. Now the next thing we need to do is how much area in total they will cover for 1000 packages. So it'll be all of this, like this value, and this value multiplied by 1000, which will become 225 m squared, 225 m squared, and 100 m squared. So dividing this magenta by 12, magenta takes 12, cyan also takes 12, and blacks takes 8. So what we're doing in this stage is we are calculating the amount of cartridges required per 1000 packages. So now we'll do 225 divided by 12, which we get as 18.75. This will also be 18.75, and 100 divided by 8 will give us 12.5. Now this will be 19 cartridges, 19 cartridges. Now we multiply all of them by their corresponding prices. So 16, 16, 16, and 1050 for black. So 16, that's black, so 1050, 16, 16, and 16 times 19, we get 304, 304, 13 times 10.5, we get 136.5, and 16 times 5 is 80. Now once we add them all up, so 304, 136.5, and 80, we add them up. We get 824.5. Define the purpose of the ROHS directive. So ROHS is the Restriction of Hazardous Substances Directive. So basically ROHS the use of hazardous substances. This restriction is to prevent any harm to human health. State two specific materials that are restricted under the ROHS directive. Okay, and that's lead. If you remember that lead pencils cause lead poisoning in children, and mercury. Same thing when mercury thermometers broke, the one you check your fever with, are, are also very dangerous. Identify the following labels and state what they mean. Okay. 7 is the Mobius loop. Sorry, wrong dot. Mobius loop. And this means product can be recycled. And figure 8 is the BSI. I believe it's the kite mark. What this means is that the product conforms to the British standards for sale in Britain, of course. Outline the impact of the work of Charles and Ray Emmons on furniture design. Well, these guys, what they did is they pioneered the forming of molded plywood furniture. This can be seen in the lounge chair wood or dining chair wood. Um, this had a huge impact on developments that are used by IKEA, for example, as well as Werner Payton, who developed the S chair with fiberglass. Figure 9 shows steel beam supports for a wooden floor. Give two reasons why an I-beam cross-section is ideal for the main support. Basically, I-beam means that the beam looks like this of its cross-section. I-beam is a common stock form, which means it's available in a large variety of forms. Variety of standards. I-beams also reduce weight while still maintaining its form, or still doing its purpose to the same extent. That's all the questions.